In this video, we're going to look at ways of counting the number of distinguishable permutations. And I often call this the Mississippi problem because that's a really good illustration of this problem that's easy to remember. And here's an example. Let's start with an example. And that is, how many different ways can you rearrange these letters? Let's do H-A-L-T. Well, if you think about these letters, we can rearrange them a lot of different ways. We could do A-L-T-H, but we're not going to repeat them. And so in some ways, this is just like people in a row. If you think about the problem people in a row, we have 4 different spaces and 4 different letters. So 4 places can go the first time, and then 3. Why 3? Because once you use up a letter, you can't use it again. And then times 2 times 1. Or 4 factorial, or 24. So there's 24 ways to rearrange the letters H-A-L-T, halt. And in general, if you have n letters, then you'll be able to rearrange them in factorial ways, as long as the letters don't repeat, and as long as none of the letters are the same. Let's look at a problem that looks the same. So let's look at math teacher. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So you'd think it might be 11 factorial. But here's the difference. Watch what I'm going to do. I'm going to erase this T and erase this T and then change their positions. And if you notice, when you do that, you can't tell the difference. In other words, you can't tell the difference, or you can't distinguish between the 2 T's. And because of that, if we change those 2 T's, then you end up with M-A-T-H-T-E-A-C-H-E-R with the T's switched, but they look to us identical. So that doesn't work. So the question is, how many distinguishable permutations? That is, how many permutations will you be able to distinguish between? And the answer is pretty simple. At the top would just be 11 factorial, because that's rearranged, but then you have to divide it, and you have to divide it by how many letters. So let's look at which letters repeat. We already said the T's repeat. There's 2 repeating T's, so that's 1, 2, so you divide that by 2 factorial. Is there any other letters that repeat? There's an A, and there's an A, so that's 2 factorial. And is there anything else? There's an H and an H, so that's 2 factorial, right? So that this one right here, this is for the T's, and this one is for the A's, and that one's for the H's. What about E's? Are there any E's? There's 1, 2 E's, 2 factorial, and that's for the E's. So that's going to be your final answer there. The easiest thing to do is divide that. 2 factorial is just 2, so that's 2, 4, 2 times 4, 8, 16. So it's 11 factorial divided by 16. Let's do 11 factorial divided by 16. You get 2, 4, 9, 4, 8, 0, 0. Still a lot of different ways to do it, but less because some of the problems are indistinguishable. Let's look at another example, and then we'll look at the Mississippi problem proper. Let's look at T-A-T-T-L-E-R, Tattler. So Tattler, let's see the number of distinguishable permutations. There's 1, 2, 3, 4, 5, 6, 7. 7 factorial. And let's see if any letters repeat. The only letters that repeat are the T, and that's going to be 3 of them, so that'll be 3 factorial. So it's just 7 factorial over 3 factorial. That one I can actually do in my head, right? That's 7 times 6 times 5 over 3 times 2 times 1, and then that's just 30. That's just 210 times. Now, why do we call it the Mississippi problem? Well, if you look at the word Mississippi, there's a lot of repeating letters. Most people know how to spell it. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. And let's see what repeats. The I's repeat. 1, 2, 3, 4. There's 4 I's, right? So that's for the I's. Then there's 1, 2, 3, 4 S's. And there's 2 P's. I want to make sure that I didn't forget any. So the I's repeat. Literally what we're talking about is if we switch these 2 I's, we would not be able to distinguish between those 2 permutations, so they wouldn't count. But 1, 2, 3, 4 S's, 2 P's. I think that we're done. So that's 11 factorial over, now 4 factorial is 4 times 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1 is 12, 24 times 24 times 2. And I'll just do that on my calculator real quick. 11 factorial divided by parentheses 24 times 24 times 2. And you get 34,650. And they'll ask you, these are almost always asked with letters. You could do other problems, but almost always they'll give you a series, a word, and they'll ask how many different ways can these words be rearranged. And the top is always n factorial, where n is the number of letters. And then on the bottom, you could say k1 factorial, k2 factorial, etc., where the k's are the number of repeated letters. Though I think it's actually better to, rather than memorizing a formula, just memorize the Mississippi problem. It's 11 factorial because there's 11 letters. It's 4 factorial because there's 4 I's. It's 4 factorial because there's 4 S's. And it's 2 factorial because there's 2 P's.